In this presentation, we're going to be looking at embedding STEAM into your curriculum. More specifically, out of the three elements of STEAM inquiry, we're going to be concentrating on connect, which is also known as collaborative inquiry. When we think about connection, it is what it sounds like. It is a communication or connection between different disciplines, grade levels, ways of thinking, technologies, and it's also connection between people. This is why we think of it as being a collaborative inquiry. So there are two questions we can ask. We can ask, who are we connecting? So we are connecting a group of local or global learners who arrive at a common outcome via multiple pathways of knowledge. And we're going to explain on examples later on what that means. And we can also think about what we are connecting. And learners are connecting concepts, disciplines, and contexts in order to create and explore. When we are doing STEAM and we are doing inquiry in general, there are different criteria that we have to be aware of. One of them is awareness, which means that students are working together as a group with a shared purpose. We also have to think about motivation. Students work together and drive to gain consensus in problem solving or idea development. So students need to be intrinsically motivated to do this inquiry. Students participate in collaborating and expect others to participate. So there is an ethical element in this, because without other people's participation and your own participation, the inquiry cannot happen. And when because this is community-led inquiry, inquiry led by community of learners, students negotiate and collaborate together to find a middle point in work process and product. In other words, they negotiate where the inquiry should be, and they negotiate what the product should look like. And in the process of inquiry, students proactively engage with the group rather than waiting and seeing, rather than being retroactive. And just like in a design process too, there's a step of reflection where students think and consider alternatives as they review the work process and product. So I'm going to show you some examples of STEAM that I have done with my students. Again, mostly as a mathematics educator. And I'm going to show you how I embed STEAM in math education. So the first thing that I do in my classes, and what I've been doing for about 10 years now, is math walks and trails. And math walk, which is a sequence of steps within a community or a building or a city, and involves connection between art, science, history. There's a community connection, and it connects grade levels K through university. So when we were talking about connecting, this is the example of what we are connecting through math walks and trails. And here's one example that a specific example of a math walk is going through Halsey Institute of Contemporary Art and looking at the connection between different disciplines. So here's an example of an exhibit that happened about 4 or 5 years ago by Lonnie Holley, and this is called Not Olympic Rings. And you can see that definitely this sculpture has some geometric and mathematical properties, but then you can ask yourself, what does this do, and how does this connect in terms of art, in terms of history, in terms of a deeper meaning. And similarly, students generate questions that connect them to their formal mathematical knowledge in different, not just at art exhibits and art spaces, but also at different museums like Maze Brown Natural History Museum. So, for example, uh, students understand measurement and scale and try to make sense of this in the context of paleontology and geology. And students gain deeper understanding of structures and biological structures through noticing algebraic and geometric structure, like in this example here. So the second example of connecting is mathematical poetry. So here's an example of a mathematical poem by that's based by it's which is based on a work by Japanese poet Nanao Sakaki. So within a circle of 1 meter, I sit alone listening to classical music. Within a circle 10 meters large, I am in my garden picking tomatoes, teardrop and indigo rose. Within a circle 100 meters large, I say hello to my neighbor. So we see a mathematical pattern as this person describes their community. And then this mathematical pattern keeps increasing. So towards the end, we see within a circle 100 million kilometers large, I see Venus dance around the sun. And within a circle 10 billion kilometers large, I wave goodbye to our sun and say hello to the universe. So one way to collaborate and to connect the learners is to create online collaborative spaces to explore themes in poetry. So here's an example of a Google Doc with a mathematical poem that we just saw, and students commenting on different features of the poem, both mathematical and non-mathematical, adding different images and different formulas, etc. And here's an example of connecting mathematics, connecting learners, in this case, connecting languages and poetry. And this is an example of a mathematical poem by a student in using Chinese characters. So the student Helen is native Mandarin speaker, and she shows the structure of mathematical poem where each line is represented one symbol, which represents one syllable, and the student connects poetic meaning to geometric meaning. And then here's the translation of the same poem in English. Similarly, this is a mathematical poetry in Arabic where each line first contains 32 words, and every time the number of words get divided by 2, and you get this exponential shape here. And again, students connect mathematics to the actual meaning of the poem. And this connection can then be taken from poetry to the actual numerical structure of each line, where the first line has 32 syllables, and every time it gets divided by 2. The third example is students collaborating on mathematical compositions. So students create sequences of notes in music platforms like GarageBand or Online Sequencer. So they create notes that are equally spaced. In this case, there's each note is showing up at every second line, and this one is every third line. So students can explore different mathematical concepts like arithmetic sequences, common multiples, etc. And the collaborate aspect here is students are composing together. So students create compositions based on mathematical rule, and this depends on the grade level. And students name the composition, explain how they use math and music together. And so this is the aspect which is negotiating. Students as a community of composers decide what makes a composition good, and they decide on criteria for evaluating their work. And now it's up to you. Just using this as some starting points or starting ideas. How can you have your students collaborate as learners and connect as learners and create a community of practice and community of learners? And how can you have them connect different disciplines, different ideas, and different spaces and the grade levels uh, to create successful STEAM collaborations and STEAM collaborative inquiries?